So fine, as you can see on the screen, we have chapter number 3 to discuss today, inshallah. Fine. Chapter number 3 is talking about programming constructs. What are the things that we are going to use in C# programming that makes our program, the C# program, which are called programming constructs. For any language, whether it is C# or Java or PHP or Python, any language will have those constructs, its own programming constructs, okay, its own keywords, its own way of using these constructs and all. Fine. So we'll talk about the C# programming constructs today that makes the C# program. The objectives of this chapter is examine the anatomy of a simple C# program, explain C# literals, variables, and keywords. In the first thing, like we try to understand what is the C# programming program and how it looks like, what are the different parts of the program we have in a simple program. Then in the second objective is explain C# literals, variables, and keywords. This is also very important in any programming language, the literals, the variables, keywords. The third objective is describe C# data types, which is also very important. Any programming language, its data types are very important to define the data in the program. Then explain the operators and the expressions. With this, you will be able to write a C# program for doing simple tasks like, for example, finding the area of a circle, or solving any mathematical equations, right? So straightforward mathematical equations we can solve by after completing this chapter number 3. So these are some objectives of this chapter number 3. So let's start with the anatomy of a simple C# program. On the screen, what you see is a simple program that display a message called my first C# app, hello world, and a new line and a read line. So we got to see what are these things. Namespace, simple C# app. This is the project name itself that we are doing. We have seen in the last semester about creating a new project in C#. Right. So when we create a new project, the name of the project becomes the namespace under which all the programs will work. The program, we have the class program, and in this program we have a main method, public static void main, with a string arguments. Now this static void main, this is a main method. What you see here is a main method that every program in C# must have one main method that is the start of the execution of the program. The program starts running its execution from the main method. Like in Java, if you have taken Java, Java also has a main method. Okay, so here the same concept, right? This main method takes one argument, that is the string array argument that represent the command line argument. Wherever you want to pass to the main method, you can pass through these arguments. But for simple programs, we don't pass any arguments to the main method while we execute this program. Moving ahead, we have something called static and void. Static and void. Static means that this method, this main method can be accessed and executed without creating any object or an instance of this class. Right. So that's what the static method means. Void, it means this main method does not return any value after the execution. At the end of this method, we don't have any return statement. That means it does not return any value back after the completing the execution. It does not return any value. That's what void means. This is, in this place we can replace with the data types like integer or int or float or double, right? We see the data types later. So it does not, it's this static method does not return anything. Then we have a main, that is the start of our application or of our execution of our program. And we have the arguments inside this program. So the program starts from the main method, and inside this main method, we write our code that we want to execute or that we want to run in this program. Okay, so now let's try with this. I think I had this Visual Studio. Now let's try. I'll try to do it from the beginning and with a new project. Okay. So we're going to select the console app that supports C#, and we're going to give the name of this project M109 session 2. Okay, create the project. So as you can see on the screen, the namespace is used here, M109, and the class program, and we have the main method, right? With the string arguments, we have console.writeLine that writes a message on the screen. When we run this program, our output is simply hello world on the screen. So as you can see, this is our hello world as an output of our program. It's very simple code here just to print a message hello world, right? In our last lab file, there was a program that asked you to do that I asked you to do as a lab session to display the message, your ID number, your name, and so on, just by using writeLine. Okay, I hope you have done that to understand this. Fine. Now we are going to make use of this console. Console is a class under the system, and console has a number of methods that we use here for different purposes, right? So in the lab 1 activity file, there was a link for you to open this console class and find what are the different methods in the console class, where you have the write line, write method, read line, read method, and so on, right? I hope you have done that. Fine. Console has a method called write line. That method is used to write a text string to the output stream on this screen. Okay, it has another method called write. One is write line, the other method is write. We have method called console.write. Okay, welcome to C# programming. So what is the difference between these two methods is that write line method is going to print the text, whatever we give the text is going, it will be printed and will move to the next line, whereas write method, the cursor will move to the next line, whereas write method will just simply print it and the cursor is stay in the same line. Okay, now to test it, let's say for example, if I'm using just simply write line, right, and I run this program, and I see that after this hello world there is a line space here, that is the effect of write line. Okay, Now, if I am using just write instead of write line, and we see what is the effect, there is no line. It means that write will just write the message and stay in the same line, and it will not turn the cursor to the next line. It will not take the cursor to the next line, right? So that's the difference between write and write line. That's the difference between write and write. If you want to continue any two messages in the same line, for example, I want to put welcome to C# programming and then hello world in the same line. So first line I use write, the second line is write line, right? So now let's see, we have welcome to programming and hello world in the same line, because the first is write one, the write does not takes to the new line. Okay, so if I replace this write with write line, then we have these messages in two different lines. Okay, so I hope you got the difference between write and write line. Right, clear? Right, this is the difference between write and the write line. Fine. I've been using this two slashes to to stop the line to execute, to stop this line to execute. This is called comments. These two slashes is called comments. Now comments are used to write the description of the program. For example, I want to write it here as my first simple program, and this text, whatever I put in the comments, right, will not be executed, and it is called single line comment, because this work only for one line, the next line will be executed. Okay, so this is called comment. So these comments are used to describe the program. If something you want to explain about the working of the program in short, okay, it's not in detail. Comments do not write comments in detail. In detail in the sense, don't write many comments, or don't elaborate the comments. Comments are just to explain that what is this program is, or wherever there is a necessary that we need to put some comment to explain the program or the program constructs or the logics of the program, we can add the comments. Otherwise, we don't need to add any comments, right? And it is optional. If you add it, it will help you to read the program. If you don't add it, it's okay. You don't need to add it, and it's okay, the fine not to add it. Okay. So looking back at, sorry, brother.
I have a question about the comments.
Yes, please.
There is people said like in the TMA put a lot of comments so to give you like higher degree or higher score on the TMA and for the resembling.
Well, comments are not the purpose of to get the similarity or to avoid the similarity. No. See, whenever you write any program, comments, what is the use of comments is just to explain the program for the programmer. It's for the programmer who read the program. When you write any program, for example, you are writing a program to find area of a circle, right? You want to describe this program in one short line. You put at the beginning on top, like after the class or before the main method, one comment saying that program to find area of circle given the radius, right? Inside this, you don't need any explanation for the programmer, because the one who is reading the program is a programmer. He understands the program constructs, he understands everything. It's not for the users who use the program to to do their job, right? Comments in the program is for the programmers. For example, let's say that we are working in a software company. We are the developers, we are the programmers. One programmer does some job and gives his code to another programmer. The another program tries to read the code so that he can continue the code. The second programmer must understand the first programmer code so that he can continue in the same fashion. In this case, the first programmer will describe something, right? Some logics where he has used, some construct where he has used, and what purpose he has used by comments, by using the comments. So in the same way, when you are doing your TMA, right, or if it is a final take-home exam, comments are required there. But in short and just in brief, you don't need to add too many comments. When too many comments are added, this will distract the reader. We don't need too many comments. And if the tutor or the grading person sees that there are too many comments, he can detect the grade saying that there are too many comments, will distract reading the program. This is not the good way to write the program. At the end, you are learning a programming language. You are learning how to write the programs. So you have to follow the good practice of writing the programs and making use of different kind of things to avoid plagiarism and to avoid this and that. That's an I don't think so. That's a good students will do these kind of things, right? So just comments, use it for its purpose. Don't use it for other purposes, right? So this is what I can say for this.
Okay, thank you.
Okay. Fine. So we have seen the read line and write line and write method. Coming to the read method. What does the read method does is that it allows you to enter some information from the input stream, what is generally from the basic input device, that is from the keyboard. There are two methods, which is read and read line. Whereas read line is to receive the information until you press the enter key. All the information is read. So whenever we enter something, the whole line of data will be copied to the variable and a form of when we say read line. And in a read method, it will capture a single character. The first character, whatever you enter, will be captured. Okay, the single character. So there is a difference. Read line will read the entire line, whereas read will just capture a single character or just read a single character. So when we see that whenever we want to read a line of data, for example, let's say enter your name. When we say enter your name, you are going to enter the name, right? It's like more than one word. So it will be in line. So we use the read line there to read the complete line. Or let's say we have another option, enter your, let's say gender. So gender is F or M. Let's say we say give an option of F or M. F for female, M for male. So there you need only one character. So in that case, you don't need to use read line. Although you can use read line and you can read the character also as a string. But if you just want to read one character, you don't need read line. You can use read directly. Just say console.read will read the one character. Will read one character. Now just to understand this, let me try to use this read and read line. I'll simply say console dot write, enter your name. You are going to enter that as a string, right? String name equals console dot read line. Now this simply read the name and assign to the variable name. So we'll come to that, what is a variable, but just to, I'm giving you an idea of read line here. Okay, console dot write line, I'm just gonna write that name again. Okay, or if you want to write Khas, I'll just write the name. Just we'll see that once we enter the name is printed again by using this write line statement. Okay, so now let's run this one. Now it asks me to enter your name, and it is in the same line. It is asking me, and the cursor is kept in the same line. So I'll say Muhammad Suleiman, and the Muhammad Suleiman is printed here, which is the right line, right? That is the right line. Fine. So to read this name, that is one line of data, we use the read line. Okay. And if we want to read a character, for example, I want to read a character called gender. Okay. So I'll say console dot read one character. Right. So I don't need not embracing camera into char. Okay. So this reads in a form of integer. So I'll just will convert it into string. To char. Let's say try to convert to char. Okay. And I'll just now print that character gender. Fine. What happened? Spelling. Now first of all, I'll just write the name, for example, and now I enter the character M. The M character is printed, as you can see here. Fine. So it is reading one character. Okay. So this is the difference between read line and read, and most of the time we are going to use the read line, right, for general programs. In our general programs, we are going to use the read line function. Okay. So that's about our first simple C# program, and I explained these constructs: static, void, main, the parameters, and the logic of the program within the main method, where we use the write line, where we use the read, and so on. Okay, write line, read line. Okay, fine. Moving ahead, literals, variables, and data types. C# program is a collection of tokens, comments, and white spaces. Tokens are nothing but the words what we are going to use or in the program. Every word is a token. Every word is a token. So tokens can be of 5 types. It can be keywords given by the C#, identifiers or variables, literals, operators, punctuators. These can be the tokens. Comments, we discuss about comments, what is a comment, and the spaces between the words is what is called the white spaces. Okay, so the program is a collection of tokens, comments, and white spaces. If you look back into this program, these are the tokens: static, void, main, string. These are all tokens, right? And these are the comments. Fine. And space between these are the white spaces, what we see here, right? So this is what a program is. A program has these things, right? Now these tokens are further of 5 types: keywords, identifiers, literals, operators, and punctuators. What are the keywords? These are the words that are defined by the C# program and has a predefined meaning, and you cannot use these words for your own purpose. It has to be used for what it is defined. In the sense, we have something called string, right? I use the string to define a string variable. Where is that string? Yeah. So it's a keyword. We cannot use this string word for our own purpose, right? String has a predefined meaning that is used to, it's a string clause and used to represent any string variable or string object, and hence we cannot use this string for our own purpose. Static, like in a main method, static void. Static has a predefined meaning. You cannot use for your own purpose. Static word. Similarly, we use void. You cannot use void for your own purpose. Void has a meaning, right? Similarly, int for integer variables or integer values, you cannot use for your own purpose. If, for, get, all these are the keywords, and keywords has predefined meaning in the programming language. And every programming language has keywords. Like you have studied Java, you find Java has keywords, right? Java keywords you cannot use for your own purpose. Similarly, other programming languages like Python or C or any other programming language has this keyword, has its own keywords, and we cannot use the keywords for our own purpose. It has to be used for the purpose of what it is defined. Okay. So these are the keywords. You don't need to memorize these keywords. Rather, when you do the program in practice, you will come to know about these keywords, right? For now, you don't know what is for, you may not know what is get, what is class, what is const. You may not know about what is const for now. But when you write a program and use a const, you'll understand what is a const and why it is used for const. Okay. So a lot of keywords, fine, are there here. So we'll use these keywords in our programs. Moving ahead for literals. Literals are any values that are assigned to the variables or as a result of expression in a program. The values assigned to a variable, okay, or the values as a result of any expression which is assigned to a variable is called literals. See literals in C#, we have the literals of different type. We have numeric literals that represents numeric values, that is the numbers, further divided into integer literals and real literals. Now what is integer literals? Can anyone give an example of integer literals? Students, what are the integer literals?
Like numbers 1 or 2.
Yeah, any number like 0, 1, 200, 200, 1, 5, 3, 5, any numbers, okay, are the integer literals. And what about the real literals? What are the real literals? Yes. Real literals are again the numbers, but these are the decimal numbers or the numbers which is a floating point or real numbers. Like for example, 1.2, right? 2.3. These numbers are called real numbers, and which are real literals. Okay. Similarly, we have the Boolean literals. Boolean literals are true or false, right? Character literals, we have single character A, B, C, D, which is enclosed in single character, or a string which is enclosed in double quotes is a string, right? Which is a string literal. So C# literal is further divided numerical, Boolean, character, numerical we have integer and real literals, Boolean we have is like the value is true false, character we have single character, or a string, multiple characters. Okay, so these are different type of literals we have in C#. Now let's see what are these. Integer literals refer to a sequence of digits. There are two types of integer literals, decimal integer and hexadecimal. To represent hexadecimal, we are going to use the 0x, right? This number will be as an hexadecimal number. You know about the hexadecimal number, that is from 0 to 9 and then from A to F, right? These are the hexadecimal numbers. So we can represent the number either in hexadecimal or in decimal. In our programs, we are just going to use these decimal numbers. Okay. Then coming to the real letters, real literals are represented by some fraction part, like for example 17.548, okay, or 1.5. We can also represent this what type of number it is, whether it is in decimal or float or double or a decimal number. Okay, F means this is a float number, D means it's a double number, M is a decimal number. The difference between them is the size difference. Float is smaller than double. Okay, so the difference is size. When it comes to data types, when you study the data types, you will see what is the size of float and what is the size of double. But at the end, if you mention, like for example 1.5, if I say like double d is equal to 1.5, so this is a double value which is assigned to the variable d. Okay, so real letters are the decimal numbers, or we can say that fractional part numbers. Then coming to the Boolean literals, it takes true or false, two values. That's a Boolean value, true or false. Single character literal, which is enclosed in a one pair of quotation mark, that is single quotes. Anything, for example, at in single quote is a character. One in single quote is a character. Two in single quote is a character. Type. If I write something like this, 1, 2, 3 in single quote, is it a character? Is it a character or not? Students, can you hear me? Hello?
Yes, doctor.
Yeah. So my question is 1, 2, 3 in single quote is a character or not?
I think
Charac
yes.
Character literal or not? See, it is not a single character, right? Anything should be a single character enclosed in a pair of single quotation mark. It is three characters here, 1, 2, 3. These are three different characters. So if I say 1, 2, 3, this is not a character. If I say 1, this is a character. Okay, should be a single character. Fine. Okay, that's a single character literals. String literals, which is enclosed in double quotes. Anything which is enclosed in double quotes, we call it as a string literals. E1 is a single character. It is a string literal if it is enclosed in double quotes. Okay, fine. We also have the backslash characters which are used for some special purpose. For example, /A for alert, /B for backspace, /N for new line, /O for null to represent null. If you want to put a backslash, we can use this. Okay, for different special purposes, we have this is backslash character literals. Backslash. We also call them as an escape sequence characters. Okay. So that's about the literals. Now moving ahead to variables or identifiers. What's a variable? A variable is nothing but a name given to a storage area that our program can manipulate, can store a data, can access a data. What happens when we define any variable and when we use this variable? Okay. for an example, let me see here, let's say like enter a number. I'll just say int x is equal to convert dot to int 32 dot console dot read line. Fine. I'm entering.
Step convert into.
I'll come to that. I'll come to that. No worries. Console dot number is now this program is simply asking you a number. So when I enter this number, will display the number is the given number. Okay. Whenever we enter this number, this is stored in X. Where we display the X value is displayed, right? This X is a variable. X is a variable. It shows you when you can see that here the comment shows local variable int X. X is a variable here. Now what is this variable? Why we declare this variable? Why we write this variable is that whenever we want to store any data in our program or use any data in our program, okay, we are going to declare some variables and put the data in that variable. And this variable is what is nothing but a name to some memory location inside your system where this value what we enter is stored. So for example, in this program, when I run this program, it asks me to enter a number. I enter 25, right? It goes and it prints that number 25, right? What I print, I don't print 25 here, I print X here. So it goes and takes the value of X and print the value of X here, right? Next time, for example, I enter 55, I get 55. Every time I enter the value, I get the same value. That is, I get what is there inside the X, right? So what happens is that in your system, in the memory, right? Let's say this is the memory where the values are stored, okay? When I declare the X int X, X is given to a memory location where the values are stored. When I say enter a value, when I enter 25, this 25 is copied here in that area. Whenever you write this X, it gets its value from the memory. Whenever we change anything to X, it will affect this 25. So whenever I see, for example, here I write the X, then I make the changes to the X. X is equal to X plus 10, right? Again, I write the X after this, changing, adding 10. Okay. Now I see I enter 25. First it is display 25 before adding 10, and then after adding 10 it displays 35. Right here 25 and here 35. So in the memory location 10 is added. When I said X is equal to X plus 10, what is X? X is this memory. So it takes the value what is there inside this memory, add 10 to it, and again it will store that to the X. So it will erase this, override this value 25 to 35. 25 to 35. So this is what is a variable is. A variable is a name given to a storage area or a memory that our program can manipulate, can access, can store the value. Okay. Each variable in C# has a specific type. That means a variable should be of some type, whether it is an integer variable or double variable or a real variable or a string variable or a character variable or a boolean variable. Okay, we will see the different data types there in the coming slides. And then the type of the variable defines what is the size of the variable. The size of the variable can be 1 byte, 2 byte, 4 bytes, 8 bytes, 64 bytes, right? So the type of the variable defines what is the size of the variable. Size of the variable defines what value, what is the range of value the variable can store. What is the range of value the variable can store, right? Fine. Variable names may consist of alphabets, digits, and underscore, subject to the following condition. These are the conditions under which the variables are gonna declared. They must not begin with a digit. Variable must not begin with a digit. Uppercase and lowercase are distinct. That means total with a small letters or small characters is not same as total or this, because there is a difference in characters. One is in uppercase, here it is in lowercase, this is totally in uppercase. These three are different variables, right? So it means it's a case sensitive. It is case sensitive. It should not be a keyword. You cannot use a keyword as a variable. Keywords, what we have seen here. You cannot use any one of these as variable. Okay. Then white space is not allowed. Any space between the two words of a variable is not allowed. And variable names can be of any length. Can be of any length. Right. So these are the 5 rules that we need to follow when we declare a variable. It can be alphabet. We can use alphabet, digit, and underscore to declare a variable, but it should not start with a digit. It should start with a character. Uppercase and lowercase character are different. Should not use keywords. There should not be any space between two words in a variable, and variables can be of any length. Now here is an activity or a question here for you. Which of the following is a valid variable and which is not valid? Gulf. This is valid. Why? Because it satisfies all these 5 requirements. I mean this rule. Okay. .NET is not a valid because there is a space here between dot and net. There is a space. It means it is invalid because there is a space. 54 Java, it is invalid because it is starting with a digit and the rule says it must not begin with a digit. So it is an invalid variable. Okay. String, it's an invalid. Why? Why the string is invalid? Students, why the string is invalid?
because the S is not capital.
It's a keyword.
No, it's keyword. It's keyword.
Yeah, because it is from the keywords. We have seen these keywords, right? In the keyword, we have a string keyword. We cannot use keywords as a variables. It says variable names, where it should not be keyword, right? Fine. So we see that how we can declare the variables. We have to follow this. Okay. Whenever you declare a variable, make sure that it has a meaningful name. It has a meaningful name. For example, you are declaring a variable to store a name. So you declare string name. The variable name or the variable itself describe that what it is, right? That is what the meaningful names. Okay. For example, you declare a variable to read a radius value. So you write the name of the variable as a radius, for example, right? So whenever you want to declare any variable, try to use the meaningful names. Try to use meaningful names. Don't use names in general. For example, int A, int B, int C. And what is A, what is B, what is C? You need to define. Okay, just for understanding purpose. Instead of that, if you say int number 1, int number 2, int number 3, or number 1, number 2, number 3, then we can say that this is number 1, this is number 2, and this is number 3, something like this. Okay. Instead of saying like if you want to read a name or you want to store a name in a variable, you say string n. Now what is n? Number or a name or a new what n? Or if you say string x is equal to Muhammad. Now what is x? X is a variable, what it is stores. We don't know. Okay. So if I say string name is equal to Muhammad, I can say that this is a name variable. Most probably it is storing a name, right? That is the benefit of using the meaningful names in declaring the variables. But it is not syntactically, or we can say this, it does not give you any error. If I use string x is equal to Muhammad, if I do this, it will not give you any error. Like I did in my program here, I said x is equal to read value. I said here before that I said string name is equal to Muhammad, right? So it does not give you any name, any error, but it is a good choice or it's good practice that we use meaningful names. Okay. Why? Whenever we declare a variable, we declare it with the data type by specifying what type of data this variable will store. When I say int a, it is means integer. A is an integer variable that can store an integer value, an integer literal, an integer value like 10, 20, 100, 200, any integer value. String p. So p is a string variable that can store any string like Muhammad, Abdullah, Ahmad, any string p can store. So this is what the data type that specifies what type of variable it is. So let's say that I want to store radius of a circle. A radius of a circle is, for example, this is a circle, and this is the center, and this is called the right. What do you call radius in Arabic? What do you call the radius in Arabic? And this is a circle. We have the center of the circle, and this is what the half of this. What it is?
نصف قطر.
Nusf al-Qatr. Yes. So this is a radius. So if I want to declare a radius, a variable to store a radius value can be real value 2.3, 2.5, 1.2, 2 like this. Okay. So I have to see what is the data type, that supports the real values. And I use the data type to define the radius. Okay. So declaration, when we declare a variable like int a or string p, it tells the compiler what is the name of the variable is, what type of data this variable will store, and the place of declaration decide what is the scope of the variable. When we can use this variable, we can use it after its declaration. After we declare a variable, we can use the variable. So in this sense, for example, here I am declaring int x here, and I am assigning some value. I cannot use this x here. Console dot write line x. I cannot write x here. It is an error because x is defined here. So after from here I can use x. This is what the scope of the variable is. Here I cannot use x because from before this it is not defined, it is not declared, so I cannot use x here, right? So the scope of the variable comes from where it is declared. Okay, where it is declared. So when we declare a variable, we use the data type and we use the name of the variables. We can declare variables something like this. We can declare more than one variable in one line. We can declare like this fashion: float variable, double variable. Float and double is for the real values, that is the fractional values. Int for the decimal values, and character variables. Okay, we can assign the value to these variables by using something at the time of declaration. For example, int d is equal to 3, f is equal to 5. We'll initialize d with the value 3 and f with the value 5. byte z is equal to 22, double pi is equal to 3.145, char x is equal to x in double single quotes. Right. This is assigning a value at the time of declaring the variable. Okay. Or we declare a variable and then we can assign the value. Later we can assign the value. Fine. So like for example here. I'll say int x is equal to 10. This is at the time of declaration. Okay. If I say int z and later I say that this tz is equal to 20, this is two steps. One is declaring a variable, the other is assigning its value. And these two steps are done in one step here. Int x is equal to 10. Okay. We can also assign the variables like this. That is a string assignment. X is equal to y is equal to z is equal to 0. It means all x, y, z will take the values 0. Okay. Fine. It is a compiler error to make use of local variables before assigning an initial value. If you don't assign a value, you don't use that variable. For example, for x, I have assigned the value 10. For tz, I have not assigned any value. Now, if I want to write these values, or okay, let's write it. Console.writeLine x. It's okay. If I want to write this console.writeLine of tz, it is an error. What is an error? Red line. It says use of unassigned local variable tz. We are using variable to which we did not assign any value. That's what it means. It is a compiler error to make use of local variables before assigning an initial value. So it's always better that you assign some value to a variable before you use this variable. Either you assign it literally or you assign it by entering from the keyboard. Now here is a simple program where we declare three different type of variables: short variable, int variable, and double variable, and we assign its values and we try to print those values here. Okay, go through this program from the top to the bottom. What you see in this program is that there are three variables are declared: a, b, c. A is of type short. Short type is also an integral type, or we can say that the integer value, which is its size is less than int, and int is for the integer type whose size is bigger than short, and double is for the real type. So we have three type of values: a, b, c. Then we make an initialization: a 10, b 20, and c is a plus b, 10 plus 20, which is 30. And then we write this by using parameters. These are the parameters we see here. 0, it means the 0, the first parameter. 1, the second parameter. 2, the third parameter. So a is equal to 0. It means a will take this value. What is the value of a? 10. So 10 will be assigned here. So you see a is equal to 10, comma, b is equal to 1. What is the first 0, 1? Second parameter b, 20. So 20 is assigned here. So you see b is equal to 20, comma, c is equal to parameter, third parameter c. C is what? A plus b, 10 plus 20, 30. So 30 is assigned here. Okay, and hence you will see what we write here is that 10 a is equal to 10, b is equal to 20, c is equal to 30. A simple program just to explain how the variables are declared and initialized.
Doctor, I have a question in this program.
Please.
Now, what is the need for console read line? If we take it out, what is the difference? Because
Yeah.
Jan will get us the
Yes.
output.
Now, what happens here is that some of the IDEs will not allow you to see this output. It will just print the output and it will turn off the output screen. And we want to stop the screen here and we want to see the output, and then we want to close the output screen and we'll return back to our program. In my case, what I'm using the IDE Visual Studio, it does not make that sense for me, right? When I use this, say int a is equal to 10, I'll simply use this like this. Sorry, a is equal to 10 and int b is equal to 20 and double c is equal to a plus b. Okay, and I'm just writing here console dot write line a is equal to the first parameter, comma b is equal to the second parameter, starts from 0, c is equal to the third parameter. Okay, comma a, comma b, comma a, comma b. Now this is the read line which is used here. Now this will do for me, in my IDE, it will do for me that it will print the output and stay and ask for me to press any key to close this window. This is the output window. Okay, in some IDEs this message is not shown. What it will show is just simply display the output and it will go off, right? We want to stop the screen and we want to see the output. Okay, that's why there it is used console.readline. Readline will stop there and until you press any enter key or any other values, anything, okay, until it reaches to the enter key, the screen will be on there. Okay, once you press the enter key, the screen will go off. That's why it is using read line here, but in this IDE it's not required. So even if I use that console.readline, okay, this does not make sense. It will wait for me to enter some value as you see on the screen, right? And then I enter, it will close the screen. Fine, so that's the reason it is given there. Okay, but with the advanced IDEs I think it's not required, but still in some IDEs if it is not, the output you cannot see, the output is just displayed and the screen goes off, we can use this read line. Clear? Okay, the next, accepting the values from the keyboard or from the user. We can use this read line to read any value from the keyboard or from the user to store in a variable, like what we did here. Enter a number, enter a radius, enter your name, right? Now there was a question about what is this convert. Convert is a class that has a number of methods to convert one type of data into another type. Now why we want to use this convert here, why this convert is required here? Because whatever we enter here in the read line function, whatever we enter, it is entered in a form of a string, in a form of characters as a string. Okay, that number we need to convert back into the number, into integer. There we use this convert class, convert to int 32. It means convert this value, whatever is entered. When we enter, for example, here I ask the user, let's say int number, fine, and console dot write line enter a number. Let's say number is equal to console.read line. Now you can see that there is an error here. What is this error? A string console.read line. It means this read line read the next line of characters from the standard input device, that is from the keyboard. So it is reading characters and it is giving as a string, not as a number, right? And it says this cannot implicitly convert a string to integer. It will not convert. The compiler will not convert automatically string to. The read line reads the string in a form of a string. Whatever you enter 1, 2, 3, you enter A, B, C, D, whatever you enter, it is entered in a form of a string. We want to convert that into integer so that we can use that as an integer value. There we use the convert class, convert dot to int. We have convert dot to int 32 of console.read line. So now what happens is that whatever we enter as it will be as a string will be converted into integer and then will be assigned to the number. So now it's okay. We can enter a number and we can display that number. Okay, we can use that number. So that's why we use here convert. Okay, so if you look back into convert, there are a lot of methods in the convert that we can convert what type of to integer, to boolean, to double, to date time, to integer 64. We also have other like C, to boolean, to byte, to char, to date time, to decimal, to double, integer 16, integer 32. This is 16, it means 2 bytes, 32 4 bytes, 64 8 bytes. Okay, small but sign byte, single string, unsigned integer, unsigned 32 integer 64. Lot of methods are there that convert one type of value into another type. Okay, so convert is a class again where we have different methods to convert one type of value into another type. Okay, is that clear? Student, is that clear?
Yes, clear.
Thank you. Constant variables, any variable that we want to fix its value and we don't want to change the value during the execution of the program, then we can make that variable as constant by using a keyword called const, C-O-N-S-T. So const int rows is equal to 10. The rows value is fixed. During the execution of the program, you cannot change the value of rows. For example, if I make a variable int f is equal to const int f or const double pi is equal to 3.14157 fixed. Pi is fixed now. I cannot change the pi value during the execution of the program. Somewhere here, if I say like pi is equal to pi plus 2, right? You see that there is an error. It says local constant double pi. The left hand side of the assignment must be a variable, property, or index. Why? Because pi is a fixed value and we cannot change its value during the execution of the program later. So if you want to see that we want to use some values and we want to keep that as fixed values and we don't want to change its value during the running of the program, then we can use this const keyword and we can make the variables, any type of variable, as constant. Okay, similarly I can say, for example, const string university is equal to Arab Open University. So University variable is fixed now. I cannot change the name of the university throughout the program, throughout the execution of the program. So you see that whenever you want any variable to be fixed and does not change its value during the execution of the program, we can make them as constants. Fine. So this is the use of the constants. Fine, that's about the constants. Now, moving ahead from the variables to data types. What are the different data types we have in C#? Right, we have value types and reference type. Value types we have predefined types and user defined. Predefined we have int, double, float, char. These are all predefined types. Okay, user defined, whatever the variables that user defines is something new from its own side, that is an user defined variable type. Data types, sorry. Reference types, they have predefined types and user defined types. In reference type also the same thing. In reference types, these are used to store the references and not the actual values in the memory. Okay, it also has a predefined and user defined reference types. Okay. In value types, we have user defined and a predefined. The predefined, we have the primitive types, which are for numeric, boolean, and characters. Okay, we have the numeric, we have the floating point, integer type, and decimal type. Integer types, signed int, unsigned int. Signed integers will take the values from negative and to positive values, whereas unsigned integers will take the value from 0 to any positive number. Okay, there's a difference between signed type and unsigned type. And floating, it's a real number, right? And decimal is also a real number. That is any value like 1.5, 2.5, something like that. These are all floating and decimal. Boolean types will take true or false. Either it takes true or false. Character types, any character like we have char, okay, or a string. Okay. Floating type, we have two data types in floating type. We have float and double. We can use float or double. Okay. There is a difference between float and double is the size. Float takes 4 bytes, whereas double takes 8 bytes. Okay. Memory in the system. So we always use the double, okay, instead of float, because it is more safer, that it takes some memory, but any value the float will accept. Okay, any real value the float will accept. In numeric type, we have decimal type, okay, that will store decimal values, okay, which is of 128 bit. Okay. Integers, unsigned type, we have byte, u short, u int, u long. Unsigned int, unsigned short, unsigned long. The unsigned here, it means it takes the value from 0 to any positive value. 1, 2, 3, 100, 200, 1000, depends on the size. Byte will be like 1 byte, the size is 1 byte, so it means it will take 0 to 255, value 0 to 255. This is the range of what byte accept. Similarly, short is of 2 bytes and int is of 4 bytes and long is of 8 bytes. Okay, so their size is different and the range of value they take is different. Okay, integers, the signed integers, we use this int, long, short, s byte. Okay, the same thing, but these value takes from negative values. Like S byte is 1 byte, it takes from minus 120, 127 to plus 128. Short takes from 2 byte, it's 2 byte, it takes a range of value from minus to plus, negative to positive. Integer of 4 bytes, long is of 8 bytes, again it takes from negative to positive values, whereas unsigned takes only from 0, it will not accept any negative values. Okay, so those are about the integer. We are going to use in our programs these data types. Int, okay, most of the time we use int, and we use this double most of the time in our programs, double and int to declare the variables, and for characters we use char. Reference type is further divided into user defined and predefined. In user defined can be classes, arrays, interfaces, delegates, and predefined string type, object type, right? So these are predefined. We can use this in our programs. So these are the data types, some of the data types that we can use in our programs to declare some different type of data. So mostly we are going to use int, double, char, string, 4 data types in our programs. Okay, fine. Moving ahead, operators and expressions. What are the different operators that we can use in our programs? Operators and expressions, different operators that we can use in our programs. We can use arithmetic operator, that is plus, minus, multiplication, division. Okay, modulus operator, that is the reminder operator. We can use relational operator. Relational operators are less than, greater than, less than or equal to, greater than or equal to, not equal to. These are all relational operators. We can use logical operators, and, or, not. We can use assignment operator, that assigns a value, which is equals, that assign a value from its right hand side to the left hand side. For example, a is equal to 10. Assign 10 to the variable a. This is an assignment variable. Can use conditional operator. We have a conditional operator. We'll see what is this conditional operator. We can use bitwise operator and the special operators. We'll see some of these operators. Let's say, for example, arithmetic operators. We have plus that adds 2 operands. For example, if a is 10, b is 20, plus will be adding a value and b value, that is 10 plus 20, 30. Minus, subtract a minus b, a is 10, b is 20, the result is minus 10, right? 10 minus 20 is minus. Multiplication, a multiplies b, 10 by 20 is 200. Do you have any questions, student? Student, do you have any question? Open your mic, I think. Can you please mute your mic? So, fine. Similarly, we have division divides b by a, for example, 20 by 10 to reminder operator, percentage will return you the reminder after division. For example, 20 by 10 is, it goes 2 times, and what it reminds, remaining 0, so it will give you 0 reminder. So then, do you have any question? We cannot hear you. Please mute yourself if you don't have any question. Okay, we have other special operators plus plus and minus minus. These operators are called increment operator and decrement operator. Plus plus increment a value of the variable by 1 and minus minus will decrement the value of variable by 1. Okay, so let's try to understand this in this program. We have three variables here, int a, int b, int c. A is 21, b is 10. We add this a, b and assign to c. C is equal to a plus b. So what is the value of c? C is 31. A minus b, 21 minus 10, c is 11. A multiplied by b, c is 210. A divided by b, c is how much? 21 by 10, 2. It divides 2 times. A mod, the remainder is 1 because it divides 2 times, remaining 1. A plus plus 21 plus 1, 22. So it will give you 22. A minus minus 21 minus 1, 20. Right? Fine. So, but in plus plus and minus minus, there is something called pre-increment and post-increment, pre-decrement and post-decrement. Okay. So we will study that inshallah. What is this pre-increment, post-increment? Okay. In the coming slides, we will see that very soon, inshallah. Okay. But you got an idea about plus, minus, multiplication, division, reminder. Fine. This is the output of it. The next relational operators, which is we used to compare two values and it returns true or false. It returns a Boolean value, whether it is true or not. For example, A is 10, B is 20. If I say A is equal to B, it's not true. Why? Because they are not equal. We have to use double equals here. A not equal to B is true because they are not equal. A is greater than B, not true. A less than B is true because A is 10, B is 20. A greater than or equal to B, not true. A less than or equal to B is true because A is less than. Or equal if it is true. If it is or equal, it will be true. For example, if A is 20 and B is 20, A is 20 and B is also 20. So in this case, this is true. Why? Because it is greater than or equal. They are equal, right? So if any one is true, it is true. And even this is true because they are equal in this case. Okay. So these are the relational operators. We also have the logical operators, logical and, logical or, and logical not. Logical, these are used to combine the Boolean expressions. For example, I have A less than B or B less than C. In this case, it will check these two statements. For example, if this is true and this is false, the whole statement returns true because of the or. So it will take any one of this is true in the or, right? In this or. So it is called or operator. It is true if any one or both is true. If both are false, it is false. If the two expressions are false, it will return the value false. Okay. And it's just opposite to or. Is that if both are true, it is true. If both are true, the and will return true. Otherwise, it returns false. And not will just swap the result. If the expression is true, not will make it false, and if the expression is false, not will make it true. Okay. Shorthand assignment operators. We can write a shorthand assignment operators. For example, if I want to write A is equal to A mod B, I can simply write A mod is equal to B. Both are same. Both are similar. If I want to write A is equal to A plus 1, I can simply write A plus equal 1. Okay, these are called shorthand assignment operators. Modulus equal, plus equal, minus equal, multiplication equal, division equal. Okay, these are called shorthand assignment operators. Moving ahead to the conditional operator. The conditional operator is a pair of operators question mark with a colon. This is called a conditional operator. How it works? It uses the expression to define the result which is based on the value of this expression. If this expression is true, this expression 2 will be considered. If this is false, expression 3 will be considered for output. Okay, so first expression is evaluated. If it is true, then expression 2 is evaluated and becomes the value of the conditional expression. If expression 1 is false, then expression 3 is evaluated and becomes the value of the expression. For example, a is equal to a is a string variable, input greater than 0, it is positive. If this is true, positive is assigned to a. If this is false, negative is assigned to a. Or in simple words, for example, let's say that I want to find whether a number is odd or even. Okay, or whether, yeah, we can say odd or even number. For example, I'll say enter a number, fine. Okay, and I'll say here entering a number. After this, I'll take a string here, string result is equal to, I'll check this number modulus 2 is equal to 0. What it is an even number, right? Raqam zawji. I will say it is even. Okay, if not, otherwise it is an odd number, raqam fardi. Okay, and I'll just write the result, console dot write line, the number is result. So what happens here is when I enter a number, this is a conditional operator, right? It will check this expression number mod 2. If it is 0, it will assign even to result, and if it is false, it will assign odd to the result. So let us run and see. I enter a number, for example 25. So number is odd. I get number is odd, right? Now let me do it for 42. Number is even. So what is happening here is that it will check this expression. If this is true, 42 mod 2, the remainder is 0 because it divides 21 times, remaining 0. So it is true. When it is true, it will take this even assigned to the result. And when it is false, for example 25 mod 2, it goes 12 times 24, remaining 1. So it is false. This condition is not 0, false. So it will take the odd and assign to the result, and the result is printed here. Okay, this is what a conditional operator is, right? Okay, now coming to this plus and minus operator. Plus and minus operator, which is called a unary operators, plus. This plus is called an increment operator. Increment operator in the sense it will increment the value of the variable by 1. It will add 1 to the variable. For example, so here I have a number. What is the number? Whatever I enter, that is a number. Console dot write line, number is number, right? So let me just run this and show we enter a number 25, number is 25. Okay, if I use number plus, it will add 1 to the number. It will add 1 to the number. Now I can print again and see what is the number here. Number after plus. So I enter number 25. The number is 25. Number after plus plus is 26. So what happened? 1 is added here. Okay. Again, I will make it twice. Number plus plus 2 times. So 1 is added there, 26. Again plus 1, 27. 25. So the number is 27 because I made it twice. Okay. But there is one interesting thing here is that there is something called pre-increment and post-increment. Let me define it. Some value p. Okay. If I say like for example p is equal to number plus plus. Can you tell me what is the value of p and value of number? What is the value of number and value of p? Number is number and p is how much? What is the value of p here? Yes, please. Can you tell me what is the output here? What is the number and what is p? Initially, I enter number. Let's say that, okay, I will assign the number here instead of entering the number here. Okay, I'll just assign here. I will not ask any number here. I'll assign number is equal to 10. Now tell me what is the number and what is p after here, after this statement here in the output, number and p. Initially number is 10 and p is nothing. We did not assign any value. We are assigning here number plus plus.
B, it will be number plus 1, which is 11.
Okay, and number is
10.
10. Fine. This is what is called post increment. Post increment. Okay. Now let's understand this. Post increment is what? Is that if the plus plus is after the variable number plus plus, that is variable then plus plus. In post, this is called post increment. What happens here is that if we assign any, we use this post increment in any expression, first the number value is taken to the consideration, to the p. What is number? 10. 10 is given to p, then the increment will happen. So p is 10, number is 11. You can see there. P is 10 and number is 11. Why? Because it is a post increment. What is post increment? If the plus plus is after the variable, then first the value of that variable is taken for consideration for assignment. Okay, and then the variable is incremented. So in this case, we get the value p as the value of the number, which is 10, and then number is incremented to plus 1. 10 plus 1, 11. This is called post increment. Okay, so you can see the difference here. Number is 11, p is 10. But if we use plus plus before the variable, this is called pre-increment. It means first increment the number and then assign the incremented value to p. So in this case, p and number both will be 11. Why? Because first number is incremented from 10 to 11 and 11 is assigned to p. So number is 11, p is 11, which is called pre-increment. So you can see number is 11, p is 11. This is called pre-increment. Fine. So in increment, we have this pre-increment and post-increment, and you should be very careful when using this pre-increment and post-increment. Clear? Do you have any doubt? students. Is it clear?
Yes, clear.
Thank you. Similarly, we also have decrement minus minus. We have pre and post. Now tell me what is the value of p and num if I am decrementing. Decrement minus minus will decrement the value by 1. If it is 10, minus 1. So now what is the value of num and what is the value of p?
It will be 9 for number and 9 for B.
Great. It will be 9 for number and 9 for p because it is a pre-decrement. First it will decrement the number by 1. So 10 minus 1 is 9 and 9, the decremented value will be assigned to p. So we have 9 and 9. And what if it is post decrement? It is 9 and 10. First the number is assigned to p and then it is decremented. Number is decremented. Fine, that's a decrement operator. So plus minus, pre-increment, post-increment, pre-decrement and post-decrement. So these are some example of it. Moving ahead, arithmetic expression. Any expression that uses the arithmetic operators is called as an arithmetic expression, and we can write arithmetic expressions in C#. Right? For example, if you want to write a multiply b minus c, we write in this fashion. We write in this fashion: a star b minus c. If you want to write this expression m plus n multiply x plus y, we write in this fashion in C#. AB divide c, a multiply b divide c. 3x square, 3 multiply x, that is x square, 3x square plus 2 into x, 2x plus 1. X divided by y plus c. How do we write? X by y then plus c. This is called what? This is how we write in C#, the arithmetic expressions. Arithmetic expressions are written in C# in this fashion. Okay, fine. So this is all what we have for you in this chapter 3, that is C# programming constructs. Okay, now here is the table showing you the operator precedency, which operators comes first and which operators comes next while they are in any arithmetic expressions. It is from left to right. First, of course, we are going to use the postfix operators like unary operators, okay, and the brackets and minus and greater than. Fine. Then we talk about the unary operators, then multiplicative, multiplication, division, modulus, then additive, plus minus, then shifts, then relational, then equality, then logical operators. Okay. Finally, it comes to assignment operators. This table shows you the operator precedency. Fine. So this is all what we have here for you. The summary of this chapter is that we have studied different components of a C# program. We talk about keywords, we talk about literals, numeric, boolean and character literals. We talk about variables, how we declare variables, how we initialize the variables, what are the different data types, and what are the operators and arithmetic expressions. So we talk about these in this chapter number 3, constructs, programming construct. Fine. So after this we have the lab session inshallah at 4 o'clock, right, after 15 minutes. In the lab session inshallah we are going to do some programs. Okay, so there is a lab activity here. Let me show you this. Yeah, this is lab 2 activity. We have some of the tasks here in the lab 2. Fine, we'll try to do this inshallah after an hour. Sorry, after 4 o'clock. Okay, fine. So the lab link is given in the LMS. Fine, you can go back and join from the lab link. Okay, Before that, let me just download your attendance here. Fine.
دكتور 4000